Hello, good morning, students. Students, today we are going to study the normalization. Okay. So before going to study the normalization, we should know what we mean by Armstrong axioms. So we already studied Armstrong axioms. Okay. So what is reflexivity? So reflexivity is nothing but if x tends to y, if x tends to y is a functional dependency, okay, then y is subset of x. Y is subset of x. Okay. So here x and y. So this means y is subset of y, x, or we can also write x includes y. So the meaning of this one is x includes y, or in simply you can say y is subset of x. Okay, so this y part is subset of x, then we say that that is reflexivity. Okay, that is the functional dependency is reflexive. Say for example, AB tends to some B. Okay, so here this is extends to Y. Okay, so B is a subset of AB, or AB tends to B, AB tends to A, AB tends to AB. All these are the reflexive. Okay, students. Okay, next one is the augmentation rule. Okay, what is augmentation rule? So according to augmentation rule, if x tends to y, if x tends to y is there, okay, so any variable says, say for example, some z, okay, so z can be added to the x part and y part, okay, so that means xz tends to yz. So augmenting a new variable to the functional dependency, okay, the z here, z is augmented to x tends to y, so that is augmentation rule. So next one is the transitivity. So we already studied transitivity. If x tends to y, y tends to z, then x tends to z. Okay, so that is transitivity rule. So next we see the union rule. What is union? See, x tends to y and x tends to z, or x tends to AB. AB. Okay, so this RHS is same. Okay, sorry, this LHS. If LHS is same, then we can union them or we can combine them. Okay, so it is going to give x tends to YAB. YAB. So this is the union rule. Okay, next one is the decomposition rule. So according to decomposition rule, if x tends to YZ, okay, sorry, if x tends to YZ is there, then we can write x tends to Y separately, x tends to Y separately, and x tends to Z separately, x tends to Z separately. So in this case, x tends to YAB can be written as separately x tends to A, sorry, x tends to Y, next x tends to A, next x tends to B. Okay, so this is the decomposition rule. Okay, students. Okay, have understood what you mean by Armstrong axioms? Do you have any doubt regarding this? See, we already discussed previously. So once again, I'm refreshing these things. Okay, now we go to the normalization. And so one by one, first normal form, second normal form, and third normal form. So as normalization is very, very important in the examination point of view, time again I am telling. Okay, students. So normalization. So what is normalization? Why we need the normalization? Normalization is nothing but reducing the redundancy of the database. Okay. So in order to reduce the unnecessary information that contained in the database, okay. So have to normalize the tables or normalize the relations. Okay. So according to the normalization, there are so many normal forms are there. First normal form, second normal form, third normal form, bias coded normal form, fourth normal form, as well as the fifth normal form. Okay. So now we are going to study up to third normal form. Okay. In the next class, we discuss the remaining things. Okay. First normal form. Okay. What is first normal form? According to first normal form, all domain values must be atomic. Okay. That is the first normal form. Okay. See here. So this is the table course detail table. This is the course detail relation. So it is having course number, module number, okay, course number, course name, course level, okay, module number, module name, status, and unit points. Okay, see, all domain values must be atomic. See here, the course number is having B774. Course name is computer science. Okay, so this is BSc, Bachelor of Science and Engineering. Okay, see, module numbers are B741, B742, 743, 744, 745. Okay, these are not atomic. A bunch of values we have placed in one cell. Okay, so this is not atomic. See here for the module name. So for the module name also, a bunch of values kept in a single cell. Okay, so status also a bunch of values kept in a single cell, and unit point also I have done in the same way. See, in the course B94 MSc, okay, so module numbers have kept in a single cell. Okay, so if you are going to put this in a separate tuple, then it converted into automatically converted into first normal form. Okay, students. students. So now, so this course detail is in first normal form. It is converted into first normal form. See, B74 CS BSc B741 programming bone basic and unit points 8, a separate tuple. Okay. Next B74 CS BSc B742. Okay. Hardware 1 basic and 8, that is under tuple. Okay. So next B743 data processing, the basic and unit points 8, that is under tuple. Okay, like that. So each and every value is atomic here. Okay, see here in this cell, this is only a single value. Here also it is a single value. So one cell should contain only a single value, then we call it as atomic. Okay, so initially this is not in the any normal form. Okay, now we have converted into first normal form. This is in first normal form. Okay. Okay, students. Now this table is in first normal form. All domain values must be atomic. Okay, nothing to do to convert the any given relation to first normal form. What we have to do is only the thing is each and every cell must contain a single attribute, like that we have to convert the relation into first normal form. Okay, so next one is the second normal form. So we'll see what do you mean by second normal form. Okay, student, next one is the second normal form. What is second normal form? All non-key attributes should be fully dependent on primary key attributes. Okay, according to second normal form, all non-key attributes should be fully dependent on primary key attributes. See, in this course detail, okay, so what is the key attributes course number? See which attributes which are underlined, those are called the key attributes. Okay, so here course number is got underlined and module number got underlined. Okay, so this course number as well as the module number are key attributes. Okay, key attributes what are course number, okay, and module number. These two are, so module number and course number are key attributes. Now we have to check that whether this table is in second normal form or not. According to second normal form, all non-key attributes should be fully depend on primary key attributes. Okay. So what are non-key attributes? Course name is a non-key attribute. Okay. And level is also a non-key attribute. Course name and course level. If you know the course number, you can get the course name and course level. Am I right? Students, if you know the course number, you can find the course name and course level. Next, module number. Okay. So module number is a prime attribute or key attribute. Module name, status, and unit points are non-key attributes. So if you know the module number, you can find the module names, module status, and unit points. Okay, so module name, status, and unit points are depend on the key attribute module number. So check whether the course name and course level depend on module number. Course name, course level depend on module number or not. Check whether module name, module status, and unit points depend on course number. No. Okay. So course name and level depend on only the attribute course number. Module name, status, and unit points depend on module number only. So this is not in the second normal form. What is second normal form? All non-key attributes should be fully depend on primary key attributes or key attributes. Okay. Okay, students. So this relation is not in the second normal form. So what are the key attributes here? See, course number is a key attribute. Module number is a key attribute. According to second normal form, all non-key attributes, that means the course name and level is a non-key attribute. So module, status, and unit points is also non-key attribute, should be fully depend on the primary key attributes. Okay, say for example, course name. Course name is depend on the course number. Okay, so module number is also a key attribute, but course name is not depend on the module number. Course name is not depend on the module number. Okay, in the same way, the course level is depend on the course number, but course level is not depend on the module number. So vice versa. Here module name depend on the only module number. It is not depend on the course. That means all non-key attributes are not fully depend on primary key attributes here. So that means, so this is not in the second normal form. Then what we have to do? In order to convert the second normal form, we have to decompose the relation. Okay. So we'll see how to decompose the relation. See here, students. See, we decompose the relation into, see, we decompose the relation this relation into one relation. Okay, we call it as course. Okay, it contains the course number, course name and level. So course name, course number and level depend on the course number. Okay, students. Okay, next table we are going to be divided into, this is the relation 1. This is relation 1. Okay, so next table we are going to be decompose into another table. Okay, so this is the relation R2. See, in this relation, course name, level are non-key attributes. If you know the course name, you can find these two. Okay. In the same way, in the relation R2, course module is the key attribute and module name, status and unit points are non-key attributes. If you know the module number, you can get this module name, status and unit points. Okay. So module name is the key attribute in the relation R2. All non-key attributes are fully dependent on module number only. So in relation R1, course number is a key attribute. Okay. So all the non-key attributes, course name and level depend only on the course name, course number. So it should be non-loss decomposition. Okay. That means if you combine these two, you should get the original relation. So in order to make that non-loss decomposition, one more table should be there. That is module course number and module name. That is the relation R3. Relation R3 with attributes, course number, and module number. Course number and module number. Okay. So check, is there any partial dependency? Relation R1, what is the key attribute? Course number is the key attribute. So course, if you know the course number, you can get the course name and course level. So course name, course level depend on course number only. Okay. Next, module number in the relation 2. Module number is a key attribute. Okay. So all non-key attributes are fully dependent on primary key attribute. So what is the primary key here? Module number is the primary key. Okay. Next, relation 3. Relation 3 is having two attributes, course number and module number. Both are key attributes. Okay. So finally, this R1, R2 and R3 are in the second normal form. Student, do you have any doubt regarding this? Please respond in the chat box. Okay, students. Okay, students. So the same thing here I am showing. So the table is decomposed into second normal form. In the second normal form, this is, we have named it as some course. Okay, and this is the module. Okay, so here course number and course name, course number, course name and level. So these two attributes are fully dependent on course number only. Okay, in the module, the module name, status and unit points also fully depend on module number only. Okay. So this is the third table, the course module table. Okay, course number, module number. So finally, the given table is decomposed into three different tables. Okay, so it need not be three tables. It can be two tables or three tables or four tables based on the problem. Okay, here this is got decomposed into three tables. Okay. So what is second normal form? According to second normal form, all non-key attributes should be fully depend on primary key attributes. Okay. So here the course number and module number are the prime attributes. Okay. So all attributes are not depend on the primary key attributes. So that means few attributes depend on the course number and few attributes depend on the module number. According to that one, all attributes should be fully dependent on both the course number and both module number. But here that is not the case. Then what we have to do, we are going to decompose that. Okay. So we'll see with some other example. See here, students. Say students, say the given relation. Okay. So this is the given relation. R A B C D. Relation R is having four attributes A B C D. Relation R is having A, B, C and D. Okay. So in this, A and B are prime attributes. If you underline any attribute, okay, we call it as a prime attribute. That means, so AB, so that means the combination of AB gives the super key or candidate key. Okay, so AB is a candidate key. AB is a candidate key. Okay, AB is candidate key. They have given functional dependencies. AB tends to D. Okay, AB tends to D. Next, B tends to C. B tends to C. So check whether this relation is in the second normal form or not. Okay, in the gate point of view, we get the questions like this. Whether this is in the second normal form or not. What is second normal form? All non-key attributes should be fully depend on primary key attributes. Or primary key attributes or candidate key, primary key, or whatever we call it as the key attributes. Okay, so what are the key attributes here? A and B are the key attributes. Okay, what are the non-key attributes? Non-key attributes. Non Non-key attributes are C and D. C and D are non-key attributes. Okay. So this is a functional dependency they given. AB tends to D and B tends to C. Even one functional dependency violates the second normal form. It is not in the second normal form. Okay. See here, AB tends to D. AB tends to D. A is a prime attribute, B is a prime attribute. So AB, AB are prime attributes. Okay. So D is a non-prime attribute. So D is fully dependent on AB. That means the attribute D is fully dependent on primary key attributes AB. So the first one is in the second normal form. The first functional dependency is the second normal form. Okay. Go for the second functional dependency. B tends to C. B is a prime attribute. Yes, B is a prime attribute. Okay. So B itself form a primary key. B itself form a primary key. No. What is primary key or candidate key here? AB. The combination of AB is a primary key. Okay, or candidate key. Okay. So what is C here? C is a non-prime attribute. So according to second normal form, all non-prime attributes should be fully dependent on primary key attributes. Okay. So what are the primary key attributes? A and B are the primary key attributes, but C is dependent on only B. This is partial dependency. This is not the full dependency. Okay, see here in the case of the first AB tends to D. In the AB tends to D, D is fully dependent on the key attributes AB. Okay, D is fully dependent on the key, but C is partially dependent on key. AB are the prime attributes or key attributes, but C is dependent on only one key attributes. So partial dependency should not be there in the second normal form. Okay, so B tends to C is violating the second normal form. So it is not a second normal form. Students, have you understood? Do you have any doubt regarding this? Okay, now it is clear that the relation ABCD with the given functional dependencies, it is not in the second normal form. We have to convert that into second normal form. Okay, how to convert into second normal form? Okay, see the AB tends to D. AB tends to D. That means D is fully dependent on the key attributes or primary key attributes. So we can decompose the relation into the relation R1 such that, okay, AB gives D. AB, A comma B gives the relation D, gives the attribute D. So this is one relation. Okay, next relation 2. Relation 2. See, in this relation, A and B are the primary key attributes. So AB tends to D. So that means if you know both AB, you can get the D. Okay. Second one is B tends to C. B tends to C. Second relation. What is B? B is a prime attribute. So if you know the B, we can get the C. So the relation R is decomposed into two relations, R1 and R2. Okay. So what are the key attributes in the R1? AB is the key attributes and D is fully dependent on the primary key attributes AB. For this relation R2, what is the key attribute? B is the key attributes. So C is dependent on B. C is dependent on B. Okay, so that means, so relation R1 and R2 satisfies the second normal form. All non-key attributes should be fully dependent on primary key attributes or key attributes. So for this relation, B is the key. For this relation, AB is the key. So D depend on CAB. Okay, C depend on B. Okay. Student, do you have any doubts regarding second normal form? It is very, very important and very easy. Please respond in the chat box. Do you have any doubt regarding this second normal form? Hello, students. Okay, thank you. Okay, next, now we move to the third normal form. Okay. So before going to the third normal form, we should know what do you mean by third normal form. See, according to third normal form, it should be in the first normal form and it should be in the second normal form. Okay, and there should not be transitive dependency. Okay, students. So according to third normal form, third normal form. See, students, according to third normal form, see, first one is BCNF, boys coded normal form. Okay, don't worry. We will discuss what you mean by boys coded normal form later. Okay, followed by third normal form, followed by second normal form, followed by first normal form. Okay, so if the relation is in the bias coded normal form, then it is in the third normal form, it is in the second normal form, and it is in the first normal form. No need to check whether it is in the third normal form, second normal form, or not. Okay, if the relation is in the third normal form, then it should be in the second normal form and it should be in the first normal form. If it is in the third normal form, no need to check that whether it is in the second normal form or not, or first normal form or not. Okay, if the relation is in the second normal form, it should be in, it will be in the first normal form. Okay, so third normal form. See, we already have seen what is first normal form. According to first normal form, all domain values must be atomic. So it is very simple. Second one, Okay, all non-key attributes should be fully depend on primary key or key attributes. That is second normal form. All non-key attributes should be fully depend on the key attributes. Then only it is second normal form. Okay, so next one is the third normal form. Okay, third normal form means it should be in the second normal form and it should be in the first normal form, and it should not contain the transitive dependency. Transitive it should not contain transitive dependency. Hmm. Okay, what is transitive dependency? We already know. In the Armstrong exam also we studied now. If A tends to B, A tends to B, and B tends to C, then A tends to C. Okay, so this should not possess. If it is in the second normal form and it contains the transitive dependency, it is not in the third normal form. It is only in the second normal form. Okay, there should not be any transitive dependency. Okay, it should not have the transitive dependency. Okay, see here. Okay, students, see, we have decompose the given relation into three relations as second normal form. So course name, level depend on course number only, and module name, status and unit points depend on module number. Okay, and third table is having the that is also in second normal form. We have to check that whether all these are in the third normal form or not. Okay, see here, uh, in this one, in this table, either any transfer dependency, say course name and level, are fully depend on course number only. So there is no transfer dependency. Here in the module number, module name, status, and unit points. Even though, okay, see module number, if you know the module number, you can get the module name, status, and unit points. Okay, see, if you know the status also, you can get the unit points. So if you know the status, you can get the unit points. Am I not? So am I correct, students? See, what is the status? Status is basic. So if you know it is basic means automatically the unit points will be 0, 8 only. Okay. So integrated, if it is integrated, we get the 11. So integrated, we get the unit points 11. Okay, advanced the 15. See, so unit points is not only depend on the module number, it is also depend on the status. That means if you know the status, you can get the unit points. See, if you know the module number, we are going to get the status. Okay, and from status, we can get the unit points. That means, so if you know the module, you are getting the unit points. So that means, so it is having the transfer dependency. It is having transfer dependency, na? So we should avoid the transfer dependency. We should avoid the transfer dependency. So in order to avoid the transfer dependency, this table has to be decomposed. Okay, so module number, we decompose that into okay, module number, next module name. Module number is the primary key, acts as a primary key here. Next module name, module name. Module name and status. Okay, so this is one relation. This relation is decomposed into module name, module number, module name, status, and another table. So status and unit points. Status, status, and unit points. Okay, so unit point, if you know the status, we are getting the unit points. So here status is act as a key in this table. Okay, in this table, module number, if you know the module number, you can get the module name and status. Okay, so if you know the status, we are getting the unit points. So now it is not having any transfer dependency now. So these two tables are in the third normal form. These two tables are in the third normal form. Okay. Okay, students, we see. See, as I'm not having the blackboard, it is difficult for me to explain all the things, but I am trying my level best to make you understand. Okay, students, so now the table is divided into which is the second normal form, that is not in the third normal form, we have converted into third normal form. Okay, so module number, module name, status. Okay, if you know the status, you can get the unit points. So here it is a prime attribute or prime key here. Okay, so here module number is the prime attribute or prime key. If you know this one, you can get these two. form. See, don't worry. In the forthgoing classes, with so many examples, we will discuss the third normal form, bias coded normal form, fourth normal form, and so on. Okay. So, what is third normal form? So, once again, I tell the first normal form. So, in the if you go to any software company, there also they pose all these questions. What is first normal form, second normal form, third normal form? Okay, what is normalization? What is normalization? Normalization is nothing but reducing the redundancy of the database. The first normal form, all domain values must be atomic. Second normal form, it should be in the first normal form, and all non-key attributes should be fully dependent on primary key attributes. Okay, what is third normal form? It should be in the first normal form, in the second normal form, and it should not possess the transfer dependency. If is there any transfer dependency, you have to bifurcate the relation or decompose the relation into such that it should not have the transfer dependency. Okay, students, do you have any doubt regarding the first, second, and third normal form? See, in the next forthgoing classes, we are going to be study the bias coded normal form and fourth normal form, as well as so how to convert the given relation into first normal form, second normal form, third normal form, and fourth normal form. Okay, because and in the gate point of view, they ask that whether these given functional dependencies are which normal form. Okay, so we have to check each and every functional dependency. First, for the given functional dependency, what we have to do is we have to find the candidate key. Okay, we already know how to find the candidate key of the given. So for each and every functional dependency, you have to find the closure. Okay, so I already discussed now how to find the candidate key of the given functional dependencies. Okay, first we have to find the candidate key of the function, all the given functional dependencies. After that, each and every functional dependency we have to check whether that is in the bias coded normal form or third normal form or second normal form, like that. Okay, finally we can decide the functional dependents are in which normal form, or if the functional dependents are in some normal form. So for example, if they are in second normal form, if you want to convert into third normal form, we can convert into third normal form, or if you want to convert into bias coded normal form also, we can convert. Okay, so this is the design part of the database. This is very, very, very important in the gate point of view and the examination point of view. Okay, students. So thank you very much. Have a nice day. So by this, I am concluding today's class.